Alright, welcome to the first video of Chapter 9, Conic sections. So we're going to start by looking at this website, and I'd highly recommend you check out this website. There's a link on my website at the Burnsville homepage, Mr. Nelson, and then Honors Algebra 2. There's a link to this, or you can just type all this stuff in. Anyway, let's go look at it, and we're going to look at the conic sections. And so what conic sections are, this is just a little applet. Conic sections, we can kind of twist this thing around. It's two cones, tip to tip, and we're going to kind of cut a plane through the cones and see what kind of shapes we can make. So right now, if we have a plane cutting through just one cone, we get a parabola out of that. So I guess I'll start messing with the slope of that plane. So I'll make the slope more steep, and what's going to happen is we've got a parabola. It's changed the bow of the parabola a little bit, so if I put it back to 1, it gets a lot less steep of a bow. And so if I go up, and now if I keep getting this closer and closer to an infinite slope, we're going to end up with a double parabola, or if we kind of zoom out, this is called a hyperbola. It's kind of like a parabola back to back. I think I'll mess with the y-intercept. It makes the parabolas get closer and closer to the center, and it ends up being an x. This is still a hyperbola. If we zoom in, we still have a hyperbolic shape here. Okay, so far we've looked at parabolas, hyperbolas. If I make this slope near 0, looks like if it's 0, we have a circle. We all know what those are. And then if we make it less than 0, a little bit more than 0, we end up with an oval. We call this an ellipse. So we've looked at the different conic sections. I'd recommend you play around with this. Just kind of tinker with the height, slant, and all this stuff. It's kind of fun. Okay, so let's get back to the notes. This is another picture of the conic sections. Here's a hyperbola. It is a perpendicular plane, or I'm sorry, a vertical plane cutting both the top and bottom cone. Circle is just a plane with a slope of 0. Ellipse is kind of a slanted plane. And then we got the parabola. So we looked at all 4 of these on the previous slide. Okay, so into the math. Graph the equations listed below on your calculator and determine which type of conic section is represented. So we're going to pull up our calculator, and we're going to type this in. It's x squared plus y squared equals 16. So we're going to go to this, and whoops, we can't type y squared in. We could type in x squared, but we can't type in y squared. So what we're going to have to do is go back to here and solve for y. So for each of these, let's solve for y. So let's grab our pen tool, and let's solve this equation for y. Okay, so the first step, we'll subtract x squared from both sides, and we get y squared equals 16 minus x squared, and then we square root both sides, and we end up with y equals plus or minus. Remember, whenever you square root a squared, we get plus or minus the square root of 16 minus x squared. That's a squared. Okay, so let's go type that into our calculator. We're going to do the positive square root of 16 minus x squared. And then in y2, we'll put the negative square root of 16 minus x squared. Okay, and when we graph this, we end up with an ellipse. And actually, this is not an ellipse. We're going to go to zoom, and then we're going to go to square. And this will give us a more accurate depiction of what this is. It is actually a circle. And so that square zoom means this screen is actually rectangular, And so it makes it so that it's more square, I guess. So this is a circle, that first one. So what type of shape, what type of conic section is represented here? This is a circle. So we'll write that in red. Okay, let's do the next one. We want to solve for y, so let's solve it for y. This one should be pretty quick. We'll add y to both sides. And we get 3x squared minus 5x equals y. And let's type that into our calculator. So we can get rid of these. That was our circle equation. And it's 3x squared minus 5x. And that equals y, so we'll graph it. And that should be pretty familiar to most of us. That's a parabola, so we can go in and type parabola on here. Alright, and the last one. So to solve for y, the first thing we want to do is subtract 25x. Be consistent, use black. So I said 25x, I meant to say 25x squared. So subtract 25x squared. We get negative 9y squared equals 225 minus 25x squared. Divide by negative 9. And then we end up with y squared equals 225 minus 25x squared all over negative 9. And then we square root both sides. And we end up with y equals the square root, plus or minus, the square root of all this stuff. So 225 minus 25 x squared all over negative 9. Okay, let's type that in. So, square root 225 minus 25x squared divided by negative 9. I think I need some parentheses in here. We want to put the top in parentheses, so we'll insert parentheses here. Otherwise, it would do negative 25x squared divided by negative 9, and it would not include that 225. Okay, let's type in the negative square root. Double parentheses this time. Oops, that was triple. 225 minus 25x squared. Close parentheses. Divided by negative 9. Close parentheses. Okay, and we graph it. And it looks like a hyperbola. The reason it looks like it's missing here is the calculator, it gets like the slope gets so steep, it can't graph an undefined slope, and it gets so close to undefined that it doesn't graph it in there. So this is truly a hyperbola. These gaps are not supposed to be there. It's the calculator's error. Okay, so let's head back to our sheet and write in hyperbola. Hyperbola. Okay, next slide. Distance formula. So this is a refresher from Algebra 1, Geometry. What is the distance between these 2 points? So if we kind of graph an xy axis here, the way we learned this back in geometry, pardon my messy xy axis, 99 negative 14 would be like something out here, over 99 down 14. And then negative 5, 139 would be somewhere up here. We want to find how far is it between these 2 points. And so what we did in geometry was we just created a right triangle, went straight down and then straight over, and we figured out the height, or the height and the width of this triangle. Then we used Pythagorean theorem, so we did a squared plus b squared equals c squared. So for this, we went down 14 and we went up 139. So it would be 139 minus negative 14. And that's going to be our height, so that's going to be our a squared, or a, plus, and then this, we went back 5, and then we went over 99, so 99 minus negative 5. Oops. We need to square all that stuff. Squared. And so this squared plus this squared is going to equal our distance squared. Okay, 139 minus negative 14, that's going to be 153. And then 99 plus 5, or 99 minus negative 5, that's going to be 104. Okay, I'm good with my square numbers, but not this good. So 153 squared is 23409. 104 squared is 10816. Let's add those together. And we get 34225. Oops. Okay, and then we square root both sides. And the square root of that number is 185. So the distance between those 2 points is 185 units. Okay, so that's the distance formula refresher. Let's go over here. What's the distance between x1, y1 and x2, y2? So the general formula. The distance squared is, remember we took the difference of the x's, so x2 minus x1 squared plus y2 minus y1 squared. And the order doesn't really matter. What would end up happening is, let's say this was 8 minus 5, that would give you 3. If you accidentally did 5 minus 8, that would give you negative 3. But when you square it, you're still going to get a positive answer. So as long as you subtract the y's and subtract the x's, square them, add them together, that'll give you the distance squared. So really the distance formula is going to be the square root of all this stuff. So let's just make it easier on myself. I'll just highlight it all and copy it. Oops. Didn't want to do that. Clone. There we go. So the distance is going to be the square root of subtract the x's squared plus subtract the y squared. So that's your general distance formula. This is something you'll definitely want to keep readily accessible in your brain. Maybe even program it in your calculator. Okay, the next refresher is the midpoint formula. So what is the midpoint of these 2 points? So we'll set up our graph again. This time I think I'll use nice neat lines. There's our x-axis, there's our y-axis, or pardon me, that's the x-axis, the y-axis is up and down. And so what is the midpoint of these 2 points? So 99, negative 14, we'll say is over here again. Just kind of put that dot in there. Negative 5, 139 is up here. The midpoint is, they just want the middle. So let's find the middle. It looks like it's somewhere in there. We could guess. That's not really that accurate. There is a formula for this. So the midpoint, you're just going to take the x's, add them up, and divide by 2. We're basically finding the average. So it's 99 plus negative 5 divided by 2. That's going to be the average of the x's, or the middle of the x's. And then, let me get this out of our way. We're going to do the same thing for the y's. So 139 plus negative 14 divided by 2. So, and once again, the order doesn't matter. The commutative property lets us add them either way. So 99 plus negative 5, that's 94. 94 divided by 2, I believe is 47. Let me just double check here. 94 divided by 2, yeah, 47. 139 minus 14, I should be able to do this without a calculator, but I'm on the spot. So 125 divided by 2 is 62.5. So our midpoint for this problem is going to be 47, comma, 62.5. So that's this point right here. Alright, so in general, I'm hoping you can kind of see what the midpoint formula is going to be. What's the midpoint between 2 points, x1, y1, x2, y2? Well, we just add the x's, x1 plus x2 divided by 2. That's a 2. Comma, y1 plus y2 divided by 2. And that's going to be your coordinate for the midpoint between any 2 points. If you were doing this in 3D, which we're not going to be doing, it would be x1 plus x2 divided by 2, y1 plus y2 divided by 2, comma, z1 plus z2 divided by 2. That's something you did in geometry. Okay, so that's it. So your in-class work for this is going to be page 567 and so on. Make sure you bring your book tomorrow to class. If you want to look it over before class, you can, but you do not have to do this until you get to class tomorrow. Have a great night. We'll see you tomorrow.